So what we did in part one of the video for section 3.7, those problems are guaranteed to be on the test. I don't think any of the problems in part two are going to come on the test specifically because I'm really bound to my calculator to get the answers. I can't really get the answers via algebra. I could get the answers if this was a calculus class without my calculator, but because we're really tied into our calculator, these probably don't make it on the test. But I'll do a couple problems, and I don't know how much. We'll stop the video at some point before we get done with the section. But I laid 5 and 6 on the screen simultaneously. If you read problems 5 and 6, if you laid them on top of each other, they're exactly the same questions. The words are exactly the same. I just changed a couple of the numbers. And that's how I'll create word problems on the test, mostly from the first video. I'll take problems from the first video, leave the words exactly the same, change the numbers. Let's do problem 6. If I feel motivated, I'll also do problem 8. Well, let me draw a picture first, get some equations and get an answer, but I'm going to really be stuck with my calculator. So as I read through this, we're building some fence to enclose a rectangular region that has I need the area to be 20,000 square meters. So my requirement is to enclose 20,000 square meters with a rectangle. And for whatever reason, one side, the widths are cheaper to fence than the lengths, and I'm not exactly sure why. Maybe there's some requirements that some of the sides can be block, the other sides can be wood. I don't know what the deal is here. But anyways, the sides facing north and south only cost me $2 a foot to build. The sides facing east and west cost me $4 to build. So of course I want to definitely get more north and south fencing than east and west fencing. Let me try to just walk through this. So for part A, I need an equation solved for the length of the field. For part B, I know what the area is. I don't need an equation for the area, but my goal is going to be to minimize cost. I want to find an equation for the cost. So let me try to draw a picture of this. So I'm building 4 sides of a rectangle. And I make the sides that I write vertical the width, and the sides that I write horizontal the length. What's my requirement? My requirement isn't a perimeter equation like it was on part 1. My requirement is that the area is 20,000 square feet, which means I know that area is equal to length times width. That means that the length times the width must equal 20,000. That's the requirement for this problem. It's a bad requirement because it's going to make the algebra horrible. So my requirement is that the length times the width is 20,000 square meters. And I'm supposed to take this equation and solve it for length by dividing both sides by W. And when I do that, I create my length equation, which is 20,000 over W. That's new, but not the tricky part, because area equals length times width. That's not new. But how do I incorporate these costs? Well, what I've written here is that the sides facing north and south, which I'm calling my widths, are going to cost $2 per side. The sides going east and west, which I'm going to call my lengths, are going to be $4 per side. So the cost is what I'm trying to minimize, and the cost is going to be the adding up the costs of the vertical sides. This width that costs $2 per foot, that width that costs $2 per foot. So I'm going to get my costs are this width, which is $2 times the number of feet, plus the cost of that width, which is $2 times the number of feet, plus the cost of this side, which is a length, which is $4 times its length, plus the cost of that length, which is $4 times how long it is in feet. So my cost equation is going to be 4W's plus 8L's. That's not good for an answer here because I need to use my calculator to get the answer, and to the right of the equal sign I could only have one variable. So just like I did in the last problem, I'm going to substitute. And what am I going to substitute? I'm going to substitute the answer I got in part A into this cost equation. I'm going to say the cost is 4W plus 8 times 20,000 over W. And of course, when I multiply an integer by a fraction, I just multiply the integer by that numerator. The best answer I could write for question B is the cost is going to be 4W plus 160,000 over W. Now I'm bound to my calculator because I don't have calculus and I don't remember what the answers are. So I'm going to have to sketch a graph. In my y1, I'm going to graph 4x plus 160,000 over x. So the x-min and x-max have to do with the width. I know my x-min probably should be 0. I can't have negative widths. I don't have a good feel for the kinds of numbers that the widths can be. But in my mind, if it was like a field was 200 by 200, what is 200 times 200? Just to give you some logic here. If each of the widths, if this field was 200 by 200, kind of like the last problem, its area would be 40,000 square meters. So I would guess numbers in the hundreds seem reasonable for dimensions. I don't think my widths are going to be in the thousands because a field that is 200 by 200 has a big enough area. So this is not very scientific. I need calculus to be scientific, and I don't have that at my fingertips. But I think widths in the hundreds are going to produce an acceptable area. So these are my widths. The x coordinates of my points are my widths. The y coordinate of my point is how much this field is going to cost to enclose. Y min I'm going to make at 0. It can't cost less than 0. And for my y max, if each of my sides, costs $4, I don't have any idea how much this. I have no idea what it's going to cost. So I'm going to make my cost in the thousands of dollars. I don't know. And I haven't done this problem for a while, which is probably good. I'm kind of fumbling for a window. I'm going to have to make a guess. I'm just going to guess at how much does it cost to enclose a fence. Maybe, I don't know if that's big or bad. Maybe $2,000, and maybe that's a horrible number, and I'll have to guess. Because we're not doing calculus, that's why I don't put these on the test. I have to do guessing, and guessing isn't always my friend. Have my old calculator out, it's fine. It probably shows up a little bit better. So let me graph my y equals, take off the stuff that I was doing in section 3.6, and graph 4x plus 160,000 divided by x. My goal is to find the minimum point. If I could see the minimum point because the y coordinates are cost and I want to minimize cost, I'm in a good place. So let me do my window. The minimum width is 0. The maximum width I made at 200 feet. The minimum cost is 0. Actually, then maybe it doesn't even make sense. I can't have a cost of 0. but the cost can't be negative. I don't know what the minimum cost is. Let me graph this and see what I see. If I don't see something good, the reason I'm not seeing something good is because I don't have a good enough cost and I don't have a feel for what the cost should be. Oh, I think this is actually adequate. So it's kind of this Nike swoosh. I'm looking for the minimum point, and somewhere down here is the minimum point. There's a point that's sitting there that the x coordinate is the width that gives me the minimum cost. The y coordinate is the minimum cost. So I'm going to search out the minimum point on my graph. And every point on my graph, the x coordinate is the width. The y coordinate is the cost. And the minimum point is going to give me the optimal width because its y will have the lowest cost. Every point is width comma cost. I want the lowest point so it has the lowest cost. So how do I find this? I use the same procedure. I use second trace calc. So I hit the second key, then the trace key, and now because I'm trying to minimize costs, I'm going to hit the minimum key. And then I'm going to trace or use my cursor and enter 3 times. And my guess is I'm going to need to round. And I'm going to round to 2 decimals because this is money. I can't have more than 2 decimals. So second key, trace key, looking for the minimum cost as opposed to the maximum area. So go down to minimum and hit enter. And my older calculator, it's a little primitive, but it shows up a little bit better. I'm going to trace to the left of the low point. I can't really tell where the low point is, so I use my left arrow, got way to the left of the low point. That's cursoring left and then hitting enter. So first I'm going to cursor left and then hit enter. When I do that, my calculator says now get to the right of the low point by using the right arrow. So I'm cursoring on the right arrow. So I'm so far away from the low point that I'm clearly above the low point, and I hit enter. So I cursor to the left of the low point, hit enter, cursor and get my cursor blinking clearly to the right of the low point, clearly so it's above the lowest point, and I hit enter. And then get as close as I can to the low point, where my calculator is saying yes. I said, well, maybe that's about the low point. And I cursor and hit enter a 3rd time. So I cursored, so my cursor was above the low point, hit enter, cursor, so my trace of my cursor was above the low point, hit enter, and then cursor and get close to the low point and hit enter. And now it's going to give me the minimum point. It says the minimum point rounded to 2 decimals is 63.25 for the width, $505.96 for the cost. So this point right here, the x coordinate is the width that I should build. Rounded to 2 decimals, it's 63.25 feet. The y coordinate is the cost. Rounded to 2 decimals, it's $505.96. That's a cheap fence. Building it yourself with equipment and stuff that you're borrowing, I guess. So here, the vertex rounded to 2 decimals is 63.25, which is the optimal width, and 505.96, which is the minimum cost. So the answer to part C, my width, is going to be 63.25, and the units are in feet. I already know the answer to part E. The minimum cost is $505.96. I don't know the answer to part part D, but I could find it using the formula L is 20,000 over W. So I was supposed to find the length and the width and the cost. The vertex gives me the width and the cost, and now I'm going to have to use a formula. to get the length. So I'm using the formula 20,000 over W. Second and quit and do 20,000 over 63.25, round to 2 decimals. I'm going to say 316.21. Didn't tell me how to round, so I'm just punting and rounding to 2 decimals. So my length is going to be 316.21 feet. That's everything. Again, this more than likely won't make it on the test. I've never put something that required a calculator in this kind of word problem on a test. In the next chapter, we're going to need a calculator to do some of the word problems, and they're going to make it on the test, but not like these. These problems can be done with calculus. The problems that we do in the next chapter, I don't teach them even calculus. But anyways, you should be able to do problem 5. It's almost the exact same question, except your numbers are a little bit uglier. Do one more problem and we'll call it the end of this section, even though I'm not doing the very, very end problem. But I think these are the important problems. So let's walk through 8. It's the same idea. I'm fencing a rectangular region. I know what the area, the amount of area that I need to enclose, and I'm trying to minimize my cost. So let me read through the problem. So a fence is being built in a large field to enclose a rectangular area that must be 10,000 square meters. One side of the area is bounded by an existing fence, so I don't need to build a fence there. So kind of what's going on here is, here's my existing fence. You know, maybe like if you build a house and you're out in the country and your person behind you already has a fence and you're fencing in your lot, maybe you're just going to do that. This is the fence that's being built. So we're going to build 2 widths and 1 length. Okay, what's required? It's required that my area is 10,000 square meters. What am I trying to do? I'm trying to minimize costs. The costs of the material for the 2 ends, those are $5, and the opposite side is $2. So first of all, I'm going to need to come up with an equation for the length for part A and an equation that has the money in for part B, and then I'm bound to my calculator. Well, how do I get an equation for the length? Well, my requirement is that the area is 10,000 square meters. My requirement is that the length times the width of this rectangle is 10,000 square meters. I'm going to take that equation and solve it for L by dividing both sides by W. And I'm going to get the length is 10,000 over W. My goal is to minimize the cost. The sides that are for the 2 ends that I'm calling them, that side's $5 a meter. This side is $5 a meter. And then it says the side that's opposite the existing fence is only $2 per meter. So the cost is going to be this side, which is $5 times its length, that side, which is $5 times its length, and then this side, which is $2 times its length. That's probably incredibly cheap. You know, $5 a meter. That's why the numbers are coming out so wacky, because I've tried to keep the numbers small to make the math easier. Makes the answers not realistic. I'm sure if anybody builds fences that these costs are really deflated. So that would be a cost equation. $10 for the sides, the 2 sides, and 2 per foot for the opposite side. Not good enough because it has 2 variables. I'm going to make the same substitution. I'm going to take this and substitute it in for that. So I'm going to get cost is 10W plus 2 times 10,000 over W. Multiply the 2 and the 10,000 and get cost is 10W plus 20,000 over W. Now I'm doomed to graphing. I'm going to put this in my Y1, and I'm going to use the same window, and hopefully I could find the minimum point. The minimum point, the x coordinate of the minimum point is going to be the optimal width. I'm going to round to 2 decimals again. The y coordinate of the minimum point is going to be the minimum cost, because each point on this graph, the x coordinates are width, the y coordinates are costs. So this calculator seems to work, just showing up better this morning. Whoops. So put my y equals clear 10x plus 20,000 divided by x. I have no idea if the window that I have in there already is suitable. I'm going to graph it, and if I could see the minimum point, I'm not going to tweak the window. If I can't see the minimum point, then I'm going to have to tweak it. I just hope I don't have to. So let me graph. I can clearly see the minimum point. The window's completely fine. So what do I need to do? I need to trace second, trace minimum, and then trace left and hit enter, trace right and hit enter, and then trace back to the middle and hit enter. So second, trace, minimum, then enter, and then use the left cursor to get my blinking cursor so it's to the left of the low point. So I'll wait for it to start going back up. Doesn't matter how far you're away from the low point, just so your cursor is blinking and it's to the left of the low point, just so it's above the low point, and to the left of it is fine. Once I get my cursor flashing and blinking to the left of the low point, I hit enter for the first of 3 times. I trace left and hit enter, I trace right and hit enter, and then I trace left and hit enter. So I trace left and I hit enter. Now I'm going to trace right and get my cursor above the low point, but to the right of the low point. Doesn't matter if you're kind of close to the low point or way far like I am here. I'm going to hit enter now that my cursor is clearly to the right of the low point. And then I'm going to get as close as I can to the low point and trace and hit enter a 3rd time. And I'm going to round to 2 decimals. I'm going to write the cost is $44. The width is 44.72 meters. The cost is $894.43. So in for my x's, which are the widths, it's 44.72 if I round to 2 decimals. And then the cost is going to be $894.43 if I round to 2 decimals, just by pulling off the x coordinate, which is the width, the y coordinate is the cost. Almost have my whole answer. I have my answer to part C. The width that I'm going to need to use is 44.72 meters. I know my answer to part E, the cost, is $894.43. I don't have my answer to part D, which is L. To get L, the length, I'm going to use the formula that the length is 10,000 over W. And I'm going to plug into that formula $44.72 meters. And I'm going to round to 2 decimals. And I'm going to get the length is so many meters. So back to my main screen by hitting the 2nd button, followed by the mode quit key. And now I'm doing 10,000 divided by 44.72. And rounding to 2 decimals, the lengths are 223.61 meters. So these just won't be on the test specifically because it's more of a calculus problem than it is an algebra problem. But setting up the problems is a nice skill to have, because if you get these problems in a calculus class and you've done them, at least you can set them up, and then you can do the calculus to get the answers. So Problem 7 would be your twin to this to work on. There's a couple more problems in the sections about cutting rectangles in the corners of paper and making a box. I'm going to skip these, and you're not going to be responsible for these. But if these intrigue you, I have solutions written up, and I can teach you how to do these, but you're not required for these. I think we're already about an hour into the videos, and this feels like enough. So we're done with the chapter. We just need to perfect the practice test. Never do I put something on a test that isn't just like something on the practice test. So make sure you understand every question on the practice test, because that's how I form the tests. I wrote the practice test first. I open up the practice test, save it as a test, shuffle the order of the questions around, change the numbers, and then make it a test.